Good evening, everyone. So my topic is real-time cyclist tracking in video using CNN and DeepSart. My co-authors are Prakash Kaut Patil and Hiramat. So these are my agenda: introduction and proposed system methodology, results and discussion, and finally conclusion. So before going to introduction, so multi-object tracking is an experimental technique used to study how our visual system tracks a multiple moving objects. So basically, the motivation behind is that object tracking in a video is a very important with the potential applications in robotics, video surveillance, autonomous driving, and even in a traffic control. So those are very important. So uh, and this is my proposed system. So proposed system, this is my proposed flowchart for the tracking of a cyclist. And here I'm detecting a cyclist in a video, and as well as tracking the same cyclist and calculating the speed of a cyclist. This is the tracking algorithm. So what is my methodology? So my methodology consists of three processing steps. First, starting with the object detection, that is the cyclist detection, multi-cyclist tracking, and cyclist speed computation. For the cyclist detection, so we used a YOLO3 detection framework. So here YOLO3 is already in object detection algorithm is there, but here the problem is it is using the darknet as a backend. It is a more computational. So that's why what we did, we changed the framework, that is with the compressed VZ network, that has a front end network for the YOLO3, and by using that one we can reduce the complexity of a network from 65 blobs to the 39 blobs. And at the same time, the usage of very small anchor settings in YOLO does not affect the performance. So that's why we recluster the size of the anchors into accomplishing by using the k-means of algorithm. So at the same time, we also reduce the computational complexity further to the 34 blobs with the help of removing the final FPN structure of YOLO3 network. And the next thing is we use the soft NMS, that is non-maximum suppression method, to avoid the severe occlusion between the different cyclists, that is the targets. So in a non-soft soft NMS methods, the bounding box where IOU is greater than the threshold and confidence is found to be lower is not removed directly, but its confidence is reduced. That is the first thing in a soft NMS. So thus the false positives of the detected targets are correctly removed, and also the false negatives are reduced. So that's why we only get a true positive things in that one. And for a tracking, particularly for a multi-cyclist tracking, we use the deep sort algorithm. So it is a deep sort working based on the distance, velocity, and the looks of a particular object. So it computes in-depth feature of every bounding box, and using similarity between deep features of a targets, and tracking logic is developed based on this one. And for particularly for a cyclist speed computation is computed with the help of optical flow. That is, optical flow is one of the best thing for detecting work based on displacement. It works on displacement of object coordinates observed from one image frame to the next image frame. So that means here in a video, each frame by frame will be there. So that is why it will be very best for and it gives the instantaneous speed of object motion in terms of pixel motion on observation image plane. And what we use for calculating optical flow, we use the locus Kanda algorithm for calculating a sparse optical flow. So with the help of to identify the speed of a cyclist, we use the distance covered by the calculating observing motion of its centroid, that is a centroid of a polar object. So from the I-1 frame to the ith frame using a formula, the formula. Next, these are my results and discussion. And these are the data set we use for training as well as testing. So one is a specialized cyclist data set, which contains 18,370 images of a cyclist, as well as kitty data set. So both are used for training of our network. And based on that one, we compared with the other algorithms which are already in the literature. So with using two different data sets. One is for the specialist cyclist detection data set. So this we got with a different average precision cyclist. So that is, we achieved in terms of easy, moderate, and hard. It is already easy and moderate, hard. It depends on the number of occlusions and number of difficult to see. Based on that one, it is categorized as easy, moderate, and hard of a particular thing. It is already there. So based on that one, we categorize easy, moderate, and hard. So our proposed algorithm is efficiently identify in all three cases compared to all other literature survey. And same thing, we also tested on the different data set, that is a kitty data set. So again, we also we also mentioned with other detectors which are already present in literature. we compared with that one, our algorithm is best doing compared to other present in literature. And these are the some sample images, sample image sequences where we have a sequence 1, sequence 2, sequence 3. So in a sequence 1, it will be identifying both with a different cyclists. With some cyclists have a pattern of shared and some cyclists do no pattern. In sequence 2, it is identifying the cyclist near the camera as well as further away from the camera or detected. In the sequence 3, the scenario is the images is very poor, that is a poor illumination, as well the cyclist is further away from the camera. So in that case also it can detect the images. So these are my computation speed of a cyclist, that means based on our algorithm. So with the help of optical flow algorithm, we find out that this is the pixels per second. And next this is our what is the conclusion is the paper is novel real-time multi-cyclist tracking is developed, which comprises of revamped YOLO3 network for object detection as well as for a deep sort algorithm for object tracking. And the speed of cyclist is computed by using optical flow. And the experimentation is proposed algorithm is carried out on a different benchmark data set. And the proposed algorithm yields higher accuracy and has an effective real-time performance as compared to other object tracking techniques in the literature. And hence we can say it is a reliable object tracking algorithm. Thank you. Any questions? Hello.
Yeah, thank you very much, sir, for your presentation.
Any questions?
Thank you, sir. Thank you, sir. I don't have a question for you. Thank you.
Okay, thank you, sir.
Thank you, sir, for the presentation.